counting principle. And the counting principle helps us when we have different categories. And we want to find the total number of possible outcomes. We want to figure out how many outcomes are in the sample space. Well, we have some shortcuts for that. Everything doesn't always work nicely with the counting principle. So we're going to learn about two things today. One's called permutation, and the other is a combination. Okay, so today we're going to learn about permutations and combinations, and these are also methods for finding our total number of possible outcomes, which gives us the total outcomes in the sample space. And that is very helpful for probability, because that's what our denominator is, the total. So here we go. On page, if you had your workbook, we'd be on page 427. The first thing it says is a permutation is a selection or group of objects in which order is important. So with a permutation, order matters. This is where order matters. Okay, so what words could we see if we're asked to do a permutation? You might see things like, how many different ways can we arrange? Or do an arrangement of objects. What's something else where order matters? Anybody play softball? What does your coach do in softball before every game? What does he or she write and hand to the officials? Oh, the lineup. Does the order matter in the lineup? Yeah. I always got to bat last. That's because I was terrible. I still am. Okay? So in a lineup, order matters. Sometimes order matters. Did Michael Phelps care about order last night when he was doing that 200 meter? What was his? 200 meter what? Butterfly last night. Yeah, the order mattered, didn't it? He wanted to be number 1, and he was. And that little guy that was shaking his fanny in front of him earlier in the day, the one from South Africa, he was number 4. That was funny. Okay. So sometimes the order matters. And so if we're running a race, the order of finishing matters. If we're in a Miss Star's Mill, the order matters. If we get first runner-up, we're getting scholarship money. That matters. Yay. Okay? So when order matters, then what we're looking at is a permutation. All right? So here we have all the permutations of the letters A, B, and C. Because the order matters, there's a difference between ABC and ACB. So there are 6 different permutations of these letters. 6 different ways we could arrange the letters. Now, this permutation can tie back into counting principle. So if we look at example 1, when it asks us to find permutations, it says we have members of a club and we want to choose a president, a vice president, and a treasurer. So we could think of this as a permutation, but we could also think of it as different categories, couldn't we? President, vice president, treasurer. So if we thought about it this way, we're actually thinking about it as the counting principle. If we have 7 members to choose from, how many possibilities are there for president? 7. Okay, we picked one. VP. 6. We picked another one. How many are left for treasurer? 5. And now we're multiplying without a calculator, so we're always going with the easiest way. 5 times 6 is 30. 3 times 7 is 21 with a 0. Okay? So there are 210 different ways we could fill those positions. All right, here it says, what if we also chose a secretary? How would it change the problem? You tell me. If we chose a secretary, how would it change the problem? So it'd be 7 times 6 times 5 times 4. And if we did 210 times 4, what does that give us? 840. Okay? Now, the next one said, well, we got an extra member. Now we're up to 8 members. And we're back down to the 3 positions. President, vice president, and treasurer. Now how many different ways? What would that be? 876. Okay, so you don't have a calculator. 7 times 6? 42. 42 times 8. That might be a little much for my head, but this is not hard. What's 42? We can take 40 and break it up in 42 and break it up into 40 plus 2. So that's 320 plus 16 is 336. How many people multiply that way in your head?
I got 326.
Once again, you guys are the ones that I'll see for math team. 3rd week of school, that's when we meet. Hey, Joseph shakes his head no every time. Every time. No math team, this will be. Joseph, have I ever shared the story with you that I accredit math team with me attaining star student status in high school? That means I had the highest SAT score of any student in the school. Yeah. It was definitely because of math team. I was very sharp with numbers because of math team. Yeah. That was good stuff. Okay. All right. So these are permutations. But we've done every single one of them like it's a counting principle problem, haven't we? We thought of it, the positions, as different categories. So to think of it as a permutation, which is really a quicker way of doing the math, we need to know what this word means in mathematics. Factorial. It is so exciting that they use the exclamation point to mean factorial. Nobody laughed. All right, so if I gave you this problem, 5 factorial, what does that mean? It means 5 times 4 times 3 times 2 times 1. It's this number times every number less than it until we get to 1. That's what factorial means. And when we do start using our calculators, which should be tomorrow, now that I have all the calculator contracts, I can assign those, so if you have your own, bring it tomorrow. I'm going to teach you where the factorial button is on your calculator. Okay, so how does that work for us and what we were just doing? We were talking about 3 positions, president, vice president, treasurer, out of 7 people. And so it ended up being 7 times 6 times 5. Do you see how this is the same as 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1? You're going, why are you doing this? Because everything's canceled. Well, 7 times everything down to 1 could be written as 7 factorial. And 4 times everything down to 1 is 4 factorial. Well, where did that 4 factorial come from? It came from doing 7 minus 3. Okay, right now your mind's a little overwhelmed and none of this makes sense. This is our formula here for permutations. The permutations of n objects chosen R at a time. So in our case, in this case right here, it would be the permutations of 7 choosing 3, because we had 7 members and we were choosing 3 for these positions. And how do we calculate that mathematically without thinking of it as a counting principle? It would be 7 factorial, n factorial, over n minus r factorial, which is 7 minus 3 factorial.
Now what does P stand for again?
P stands for the word permutation. And permutation talks about how many different possible orders or arrangements can we have of objects. Okay? So it's the permutations of 7, choose 3. Now, if I had to be straightforward with you, I would say in this case, counting principle is a much simpler, easier method for solving this problem, and that's exactly what I would do. I would not do a permutation. I think of it as different categories: president, vice president, secretary, not how many different ways we could finish. But let's go back to the race last night. There were 8 swimmers, right? How many different ways could they have finished? And what that would be the permutations of 8, choose. How many awards do they give out? 3. It would be the permutations of 8, choose 3, which is 8 factorial over 8 minus 3 factorial. Okay, how do you do a problem like this by hand? Well, 8 factorial is 8 times 7 times 6 times, I'm going to stop with 5 factorial. Who can tell me why I stopped with 5 factorial?
Because.
Okay, what do you think?
Because it's 8 minus 3.
Yep, the denominator is 5 factorial. So if I stop right there, cancel, cancel, that's all I have to do. Now, same as the counting principle. How many possibilities were there for gold? 8. Now somebody finished. How many possibilities were there for silver? 7. Now 2 people have finished. How many possibilities for bronze? 6. So permutations and counting principles can kind of be interchangeable. All right, but everything is not a permutation. And I'm going to skip this problem because we keep running out of time. Some things are not permutations. It's not always order. So, let's say I feel like it's been a really long week, and today I'm going home by the way of the Dunkin' Donuts. And I'm getting a dozen, and I'm probably not sharing. Okay? Now, when I go to Dunkin' Donuts, and I look inside, and I'm choosing my donuts, does the order that the worker puts them in the box, does that order matter? No. It's just a collection of items, and I'm eating them all. So the order that they put it in the box does not matter. And when order does not matter, it's not a permutation, is it? It's actually a combination. And so that's our next one. Combination is when the order does not matter. So this is when we do a collection of items. Or if we're talking about people, we might be forming a committee. So if we were electing class officers, that would be a permutation because we have president, vice president, secretary, treasurer. But if we were talking about the principal's advisory board, nobody gets a role on that. It's just a group of students. So when it's a group or a collection or a committee, we're no longer thinking of permutation. It's actually a combination. Now, don't be tricked, because right outside this door are a whole bunch of lockers. And those locks, what do we call them? Combination locks. Are they?
No.
No. Because does the order matter?
Yes.
Yes. So it's actually a permutation lock. Okay. So in this example, we are getting to choose from some sides. Does the order that I choose my 3 sides matter when they put it on the plate? Now, all you OCD people, you just don't even answer because order matters to y'all. Okay? So, does the order matter? No. If let's see, what do I like up here? I like rice. I like broccoli. I love salad. Okay, so I'm picking rice, broccoli, and salad. All right? So when they put that on my plate, it doesn't matter if they put rice first, then broccoli, then salad. Or if they put salad first, then broccoli, then rice. When I go sit down, all three are there. So the order that they put them on the plate does not matter. And when order doesn't matter, it's a combination. And when we have a combination, it changes our formula. Because rice, broccoli, salad is no different than salad, broccoli, rice. So if we use the same formula, we would be counting that as two different things, but it's not. It's one plate. So what we have to do is we have to divide out where we double up. So our formula for combinations is possible n choose r, the total number of objects taken r at a time is n factorial, but this time it's divided by r factorial times n minus r factorial. Okay, so in this case there were 8 items to choose from. We got to pick 3 sides. So it would be 8 factorial over 3 factorial times 8 minus 3 factorial. So if I was working this problem without a calculator, I'd do 8 times 7 times 6 times 5 factorial over 3 times 2 times 1 times 5 factorial. Because what happens to my 5 factorials? They cancel. And 6 cancels with 6, and so my answer is 8 times 7?
56.
Yes. So there are 56 combinations. So our total possible number of combinations will always be lower. Questions? Okay. The next sheet has some examples on it. And we're not going to do them, we're just going to label whether we think they're permutations or combinations. You can put a P for permutation, a C for combination. P for permutation, C for combination. And we're just doing 1 through 9, omitting number 7 because that's a error analysis problem.
It's my birthday.
That's your time?
Yes.
Huh.
Wait. I'm not gonna just let him teach you.
I don't know where it went.
No, I'll put us in that.
Okay, so all you're asking yourself, does order matter or does it not? Because if order matters, it is permutation. If order does not matter, it is a combination. Okay, so number 1, how many different orders? Well, do we have to read anything other than the question? If it says how many different orders, does order matter? Yes. So number 1 would be a permutation. When it says how many different orders, then orders matter. So number 1 would be a permutation. All right, number 2. Does order matter? Yes. Yes. Because we all want what place? First place. That matters. Okay, so when order matters, permutation. All right, number 3. Baseball players on a team. Permutation. I care whether I play first, second, third, or shortstop. If I'm left-handed, I'm only playing what base? First. It's the only infield spot other than the pitcher. All right, number 4. Does anybody see the word arrange? With arrangement, does order matter? Yes. So number 4 would be a permutation. Okay, let's skip to number 6. Alright, so we have 11 students on a committee. We get to decide which 3 students will attend the conference. Does the order that I pick the students matter? No. So 6 would be a combination. We get it? Okay, that's enough. The back of this, the back of that sheet, and then the second little sheet I gave you with the bookwork. That's your homework. And you've got 5 minutes before the bell rings. You might be able to get a nice little chunk done. These are quick.